Here's the solution for page 5 of the study guide. For problem number 13, the function f has the properties indicated in this table. Which of the following must be true? Notice that word must. All right, f is continuous at x equals -1. Well, if this is true, then we know that f of -1 equals the limit as x approaches -1 of f of x. Well, let's take a look at that. F of -1, we can see there, is 4. How about the limit as x approaches -1 of f of x? Well, we have to look at the limit as x approaches -1 from the left, which is 4, and then from the right, which is 6. Those numbers don't match. So the limit as x approaches -1 of f of x does not exist. The limit and the function do not have the same value, so the function is not continuous. This is false. How about if f is continuous at x equals 1? Well, what's f of 1? And then what's the limit as x approaches 1 of f of x? Well, according to the table, f of 1 is 2. And the limit from the left is 2, and the right is 2, so the limit must be equal to 2. The function's value and limit's value match up, so it's continuous. So this is true. So now the question becomes, why are these not true? And here's the deal. They might be true. But we don't have enough information. Okay. We don't know anything about f prime from here. We just know about f. This is asking us to check out f prime. This is asking us to check out f prime. And since we don't know anything about f prime, they could be true, but we need to know something that must be true. Okay, number 14, let f and g be differentiable functions with the following properties. G is always positive, and f of 0 is 1. H of x is f times g, and h prime is f times g prime. What does that make f? Lots of stuff given to us here. Let's start with the fact that h is equal to f times g. If we needed to find h prime, then we have f times g. What rule do we have to use? Yeah, we have to use the product rule. Derive the first, keep the second, plus derive the second, keep the first. All right, so this is h prime. But what are we told? We're told that h prime is just f times g prime. It's just this part. All right. So we know that h prime of x is equal to this, but we're also told h prime is just that. What does that mean? Well, it means that this part right here, since it's not present, means that this part right here, f prime of x times g of x, that must be equal to 0. Right? Because we'd have 0 plus what we're told h prime actually is. Well, what do we know about g? G is always positive. So g of x can't be 0 because g is always positive. Right? This means f prime of x must equal 0. Which means that f of x must just be some constant, k, because we know the derivative of a constant is 0. So f of x must be either 0 or 1. It's got to be equal to a number. Well, which one do we pick? Well, what information haven't we used yet? We haven't used this. All right? F of 0 is equal to 1. F of x is always equal to a number, so we can see the 1 matches with the k. So this k must be 1, and our answer is D. Finally, problem number 15. The graph of which of the following functions has exactly one horizontal asymptote and no vertical asymptotes? Okay, so if we're looking for asymptotes, we want one horizontal and no vertical asymptotes. So a vertical asymptote, remember, that means that we're looking for division by 0. Well, let's take a look at this. Is it possible for x squared plus 1 to be equal to 0? No, it's not. If you square a number and add 1, you're always going to get a positive value. So A is in play. How about B? Is it possible for x cubed plus 1 to be equal to 0? Yeah. It works if x is equal to negative 1. Negative 1 cubed is negative 1, plus 1 gives us 0. So it's possible for this denominator to be equal to 0, which means that this function has a vertical asymptote. We want a function that has no vertical asymptotes, so B is out. How about C? Is it possible for e to the x minus 1 to be equal to 0? Well, it is if it's possible for e to the x to be equal to 1, right? Add 1 to both sides. And this happens, it is possible for e to the x to be equal to 1. We know that anything to the 0 power is 1. So this will also have a vertical asymptote at x equals 0. So that's out. How about this one? Well, e to the x plus 1 must equal 0, which means e to the x, kind of getting confused here with all my notes, is equal to negative 1. But e to the x is always positive. E to the x can't be equal to negative 1. So this one's in play as well. So now we have to pick between A and D. What haven't we touched yet? The fact that there's one horizontal asymptote. Well, let's go back to A. How do we get a horizontal asymptote? We take the limit as x approaches infinity. Remember what happens when the degree of the denominator is larger than the degree of the numerator? Yeah, that limit as x approaches infinity is equal to 0. There it is. One horizontal asymptote. Our answer is A. For those of you who are curious, does this have one horizontal asymptote? Actually, no, it has two horizontal asymptotes. Because if we have to check the limit as x approaches infinity, but also the limit as x approaches negative infinity. And e to the x behaves differently when x is approaching infinity and negative infinity. So this one ends up giving us two horizontal asymptotes. One when it is y equals 1, the other is y equals 0. This one just gives us 1. That's why our answer is A.